So welcome everybody to episode 12. I can't actually believe we actually made it to 12. To Founders Fraud and the Future of AI. It's actually going to have a lot of fun in today's session. We're going to start in the Wayback Machine and start about where kind of SaaS came from, because we got some folks on the call who were there back in the day. I come at it from the Microsoft roots. We've got some open source roots here, obviously, and a deep amount of AWS experience here as well. I'm sure we're going to tell some really bad jokes along the way as well. So please apologize. I'll apologize ahead of that from here. And so I do have three of my favorite folks to talk to in the industry on the call in terms of Mckenty and Bill Tarr and Erwin. Before we kind of jump into it, everyone kind of want to do a just quick intro to the stream. Bill and Erwin, you guys are vets, so we'll start with you guys. Bill, you want to kind of intro to who you are and why we're here?
Yeah, sure. Hey, everybody. Hopefully you've seen me on the show before. It means you've been here before. If not, and it's just your first time, great episode to come join. My name's Bill Tarr. I do work for AWS. I'm a SaaS technologist, as I like to style myself. Like Erman, we spend a lot of time working with SaaS customers and thinking about SaaS and talking about SaaS, and now increasingly talking about AI and how that fits in with SaaS. So great to meet everybody and looking forward to this show.
Also from my side, so hello everyone. Basically everything what Bill said, right? So SaaS expert working for AWS, before that founder, before that manager and team lead at enterprises with a strong database and data analytics skills. But lately, right, so it's not only SaaS, but trying to apply SaaS best practices to the agents as a service, so to say, right? And to be honest, looking forward to be on the show today, with Joshua. I was actually writing that on my LinkedIn post today. It's like a meeting a rock star. So, Joshua, good to have you here.
Great to be here. Mike, do you want me to jump in?
Yes, please.
Josh Mckenty. I'm just old man in tech. Been writing software for a long time. Probably most notably, I worked on the Netscape browser back in the 8.0 era, and then was one of the co-founders of OpenStack while I was working at NASA. So I lived in the open source cloud universe for a while, and then went on to Pivotal, where I helped build and run Cloud Foundry platforms for 5 years for kind of everyone in the Fortune 500 as field CTO there. These days I'm working at Polyguard, where I'm co-founder of a cybersecurity startup dealing with identity and trust in the deepfakes era.
Love it. And so I do want to kind of go back to the roots of kind of, how we kind of got to the point of SaaS. And a lot of it does actually start with, private cloud and what you guys are doing at NASA and OpenStack. And it actually kind of ties to a kind of funny yet humiliating story on my behalf, which is probably why it's funny. So Joshua and I met way back when I was helping lead private cloud motions for Microsoft. And we were Microsoft, so we were very confident that we had the correct answer because, well, we're Microsoft. And Joshua comes in with his team from NASA, and Microsoft sends me in the room, and my job is to convince NASA that they're doing it wrong and they should adopt our technology instead of what they were building. And he was incredibly polite and incredibly gracious to me throughout the entire session, and I 100% was sure that I left that room having won the debate. And then I went home, turned on the TV, and there was an entire TV episode on the TV show Nova about Joshua and what he was building in NASA. And so it wasn't until I got home that night and turned on the TV for the first time that I realized he was just being polite, and at no point in that conversation did I win. But it is kind of fun how the circles keep turning, and the cloud keeps evolving, and we're all kind of there. And so we did get joined by Kamal as well. So and if you want to talk about roots, Kamal goes way back in the roots here. And so when Joshua was over with building some of the OpenStack stuff, I was over at Azure trying to build out private cloud, and that became Red Dog, and Red Dog kind of moved into Azure. Kamal was over at this thing called Amazon, which is a bookseller, and he was saying, hey, perhaps we should build a cloud service. So Kamal, you want to talk a little bit about the roots there?
Yeah, absolutely. Great to meet you all, and happy to be part of another session of the SaaS Mondays. I was joined AWS back in 2007. It was early days of AWS. We used to call it Foundational Web Services. And there were 3 services as part of that. the journey unlocked, I guess, from there, from one thing led to another. But yeah, interesting part of the way through. Worked on more than half a dozen cloud services over there, from simple workflow services, queuing services, data services, caching services, a bunch of others. And then I joined Michael and the team members at Confluent. I worked with Edison. Joshua, you may know Edison. So Edison and I, so Edison was the product side and I was on the engineering side. So we both led Kafka together for a while. And then after I guess building dozens of the cloud, these cloud services, I realized that we need some more structure to the madness of rebuilding the distribution mechanism of building the SaaS again and again. Yeah, it's not okay to, I guess it doesn't make any sense for everyone to keep rebuilding the same thing. So we built this framework to allow others to build their own control planes, I guess, or own their own platforms using that framework, and help others to automate certain aspects of the control plane as opposed to rebuilding everything from scratch.
Well, so if we actually talk about control plane and building and automating, if we kind of want to start somewhere at that NASA conversation with you, Joshua, because I do think it's a fascinating story of what you guys are building out there. And I mean, going back to painting the picture of, me as this, hotshot Microsoft guy standing in front of the room trying to pitch to Joshua and NASA, it was really kind of funny because I'm sitting in a room with a whole bunch of people who look like they work for NASA. And then there's one young kid at the back of the room who does not look like he works from NASA. But so where did you come up with this, concept? How did you guys pull it together? And, it's a really innovative thing of what you guys were doing. And how did that lead to OpenStack?
Yeah, great question. And let me preface this by saying I used to call myself the dirty uncle of OpenStack as opposed to the father or the, whatever. Like OpenStack got so big so fast, and I spent 10 years sort of flying around the world to go talk to people about what they were doing with it. And especially in Japan, I would go to Japan and they'd be like, "Oh, father of OpenStack, will you?" And I was like, "Uncle of OpenStack, please." Like there were a lot of people involved. I mean, the shortest version of the story is I was recruited into NASA to build something for them that would solve this problem they had identified. And my boss, Chris Kemp, had, he was also new to the agency, brought in this sort of special program to say, hey, shake it up, do something novel at Ames. Like, let's get on top of IT. So he was the CIO at Ames Research Center. And they had done this sort of research study across the agency to say, well, where are all the servers and how many data centers do we have and how much money are we spending keeping all our data centers secured, right? And a lot of that money goes into government regulatory security frameworks, what are called site security plans. If you operate a website or an application inside a government agency, you got to have a site security plan that covers it. These days we say FedRAMP. This is all before FedRAMP, and Chris and I were actually involved in the FedRAMP drafting process. So I apologize, but this is back in sort of plain FISMA days. And they had a count. They're like, we have at least 300 data centers according to how many SSPs we have. We don't really know because any room that has a server in it is a data center as soon as it's on a security plan. And this is insane. Like we're spending enormous amounts of money to have all these data centers and have all these servers. And most of the servers are doing one thing. And they're usually bought and stood up 5 years before the satellite they're going to support. Because that's how budget works in government is like, oh, well, we got this program approved. We have $300 million. Let's buy everything for this program. Okay, well, all the bits for the satellite, hire all the people, do all the research, but also buy all the back end stuff and rack it and get ready. So there was like capacity for missions where the satellite had crashed on launch and there were still servers in a data center that had been stood up for data that was never going to arrive. And so obviously this was stupid. And Chris was like, hey, this is really dumb. I've heard about this thing called cloud. Let's find a cloud person, get them in here and we'll do some cloud thing for NASA. I was a beta tester of S3 and EC2, and I'd become friends with Jeff Barr because I built So there was this first version of like, how do you use EC2 was this Chrome plugin called Elastic Fox. For those of you who were there was no dashboard for EC2, right? You were either using this really crappy Java CLI, or you were making like direct SOAP calls against an API endpoint, or using this weird Chrome extension. And remember, I had been building browsers. And so then I built a lot of Chrome extensions, and I was friends with the Chrome extension community. Jesse Andrews we were coworkers at Flock, and then he was on the team at NASA. He was running userscripts.org. So basically everything happening in browser plugins was Jesse's world. So he had seen Elastic Fox and showed it to me. And I was like, oh, this is cool. But it like cool from I can use EC2 standpoint, but the Chrome extension itself is crap. I can do better. And so I forked Elastic Fox and I made a thing called Spandex Fox. I was like, it's elastic, but it's tighter. And like, it was a dumb idea. I was just sort of playing around with like, there's new cool stuff and I'm using it and how we, but that meant I met Jeff Barr and I sort of met the early AWS people. And I already had a reputation from having worked on the browser and in the open source community a bit around, web stuff, let's just say. And so NASA was looking around and saying, who can we drag in to tackle getting NASA into the cloud world? And originally Chris had reached out and I was like, no, government? No, I'm doing other stuff. I was working at Tapulous at the time, which was like, we were a launch partner for the App Store on the iPhone. And, we were like doing cool games in the jailbroken world. We had millions of users and that was like fun. I was like, NASA. But the Tapulous, Chris took me out to dinner. It was basically just a particular dinner. And he was like, hey, do you want to screw around or do you want to change the world? And he literally said that. And I was like, I know you're riffing on Scully and Jobs' conversation, but it is very persuasive. And I was like, okay, you're right. Like, I want to change the world. Let's go. So I had joined and the mandate was called NASA.net originally. And it was like, which literally was a domain name squatting dispute, which by the way, I tried to deal with on the side. So NASA has nasa.gov and they do not have nasa.net. Someone else has it and they're using it to sell ads for like satellite television. And I was like, this is embarrassing and we should take the domain name over. There's a process for this. It's called UDRP, Uniform Dispute Resolution Policy for Domain Names. I'm going to just go through this process. And so I started preparing a UDRP filing and the Department of Justice called and they said, you shall not elect arbitration on behalf of the US government without our consent, which we do not give. And I was like, oh shit. Can I swear on it? Too late.
You just did.
So I was like, okay, well, the alternative is that the word NASA is protected by the Space Act. It's an act of Congress. If I cite the Space Act, they go to jail. It's minimum jail time, right? So I was like, I was going to be cute, spend like $1,200 and get the domain name back. Instead, we could just send some random domain squatters to prison. Also, that seems like a bad look. So we did nothing. And the domain name, we just never took it over. Like, so anyway, long story short, NASA.net was the original concept. And we got there and I was like, okay, 300 data centers, obviously dumb. Cloud is dumb. Let's not do that. I was really anti-cloud initially. I was like, S3 is cool. EC2 is cool. We shouldn't be in that business. We should use that. So let's build a platform as a service. What everyone needs is like a place to put their static websites or a place to run a little app. And I did a bunch of surveys inside the agency and said, we're going to support Python. And here's why Python's a good language for NASA. And we're going to go round up all these teams and get them to let us run their Python code. Basically, I wanted to build Cloud Foundry. And then we're like, okay, well, we need some infrastructure. And buying servers is really hard inside the agency for all these procurement reasons. So I need some virtual servers. Can I get some virtual servers? No. Okay. Can I stand up a virtual server environment like an IaaS? The only IaaS available was Eucalyptus. And so initially my team ran Eucalyptus. That was like part of our mandate was like, we're just going to run a cloud for the inside the agency because we're not allowed to use real cloud. And we ran Eucalyptus. And it had a bunch of bugs. It really wasn't working for what we needed. And so we contacted the founders and we're like, hey, we're going to contribute code because we've got to make this work. We needed to do these things. And they're like, please don't do those things in open source. That's what we think we're going to build commercially and sell. And I was like, oh, this isn't going to work well for us. This is awkward. And also, I couldn't hire people that wanted to work on their code base. Like, people kept churning off my team when I made them work on the Eucalyptus code. So I was like, all right, what if we just rewrote this real quick? It doesn't look that hard. And we did it in a long weekend. We built the first version of Nova in a 4-day weekend with like 5 of us. We knew cloud pretty well at that point. We're like, we actually used Bodo as the test suite. We're like, as soon as the Bodo API calls all pass, like that's our integration test. It's done. It works. So yeah, first version of Nova in like 4 days. And then 17 days later, we deployed it and replaced Eucalyptus. We already had like hundreds of users inside the agency. And we're like, everything stays the same. The CLI tools you're using will still work. The dashboard you're using won't change, but all the infrastructure is changing out underneath. And that worked. And that was roughly the same time that the partnership with Rackspace started. Sorry, that was a really long answer.
Well,
I finally got
fun story too, but you're good. Especially since that's kind of that's how a lot of us got here. Was a lot of us started in the infrastructure cloud or whatever side, and these types of movements all swept us up and along the way. And I do think one of the things I heard from that is we just saw it, we rebuilt it, and we did it. We did it in a weekend. Let's just go do. That was where Microsoft failed. Is we said, okay, this makes sense. Like, we're going to build a team, and the team's going to build a product, and the product's going to be out in 2 years. And the product was almost out in 2 years, but we killed it because by the time we were willing to ship that product, the cheese had moved. And so.
Well, and to your point, like, we talked to everyone about partnering. We talked to you. We looked at Azure, right? Chris was like, if we can buy it, let's not build it, right? Like, we're an agency. Our job is to buy. We had AWS down, and famously, this was around the Kepler mission, and they were launching. We had a thing called the PDS, which is the Planetary Data System. They had a thing called the PDS, which was the Public Datasets Project. And Amazon was like, hey, we really want to have more cool stuff in the PDS. And I was like, that's adorable. Come talk to us about it. So they came down and they're like, I was like, what's the biggest data set we could put into the PDS? And they're like, we could support a gig. And I was like, our smallest useful data set is 10 terabytes. Go home. And the same thing on the networking side, right? Like, we weren't just being dicks. I was like, I can't get an EC2 instance with more than 100 megabit of Ethernet throughput. I have 10 gig E to the rack, and that's 10 gig to SENIC and to Internet 2 and across the world, because that is the size of our data sets and that is the performance we require. Like, we can't use AWS, not just because regulatory problems meant we couldn't, but because it was a toy.
It was also for the cloud a different world at that time, right? So you were already at the stage with technology, way ahead of any cloud provider, and your needs actually were, your requirements were actually higher. And on the other side, you had that new things coming, which is actually public cloud providers. But I guess they were not there yet, right? For NASA to be supported. So you had to do something.
Well, so they got there. They really wanted to sell to government, right? And so we thought NASA Nebula was like, hey, we're solving our own problem. This is cool. We got to put a cool team together. We're like living the cloud world. And we really wanted to continue doing open source because we all had open source backgrounds, and there was a lot of problems with doing that inside the agency, and we all almost got sued and etc. And we managed to just do open source anyway. And we didn't expect it to get big, right? Like, so the partnership with Rackspace and the launch of OpenStack was not really what we thought would happen. We thought it would be cute. Like, I did another open source government-y thing right after that called OpenQuake, which is like the global standard for earthquake modeling now, for 40 countries, including Canada and a lot of the US and whatever. Nobody's heard of it. It's a 400-person open source community. It is the dominant thing in the category. It's been going for, 15 years now. But it's not OpenStack. because there's no reason for that to be cool. And that's what we thought. That's what we thought Nova would be. That isn't what happened because, well, initially because Obama wanted cloud, right? And so our first outside customer for NASA Nebula was the White House, which just like don't have the White House as your first customer ever. Our official SLA was 9 5s, right? 55.55% uptown. And then they're like, we've canceled your scheduled downtime. I was like, what does that even mean? Like, that's not how an SLA works. They're like, no, it is, because we're us. So you don't get you get no maintenance windows anymore because we need this to be up all the time. So this kind of stuff was but so the public cloud providers, AWS and Azure and everyone said, hey, we really want to sell to government because government has made it clear they want to buy. How do we work this out? And Vivek Kundra hosted a roundtable at NASA Ames because he'd come to visit our project, and then he sat down, and Sergey Brin came, and Brewster Kahle came, and everyone sat at this big table and said, how are we going to help government buy cloud? And what does everyone need to do? And out of that came FedRAMP, and also the gov regions for AWS and a bunch of other weird things.
Nice.
And then out of that came the next presidential administration, who said, "Thou shalt not use you shall use no-fluff." And so there was a couple of interesting months there where we were all in on selling to the government, and then all of a sudden the government just went away. Those were interesting times.
Yes.
Or when I cut you off, I'm sorry.
No problem. So one thing actually, so what was actually very, very successful with OpenStack is building a community. How did you do that, right? I know a lot of startup founders, and I was there as well, right? Building a community around your product is not easy. So how did that work?
Yeah, there's always luck. There's always luck, and luck is usually timing. Often for community building, luck is being authentic about a personality that you have that other people share. So shared identity is what community forms around. And this was the moment where DevOps was really starting to pick up steam, right? This was also kind of why Andrew Schaefer and I ended up becoming friends. The DevOps moment ended up being about infrastructure as code, which meant cloud. And so that whole zeitgeist of like, oh, we want to be treated not as sysadmins who are made fun of and live in a closet and have binders, but as a different kind of engineer who gets some respect and gets to use cool tools and go to conferences. And that crossover, OpenStack was a big part of that crossover. So we got lucky on the timing and the persona. And then we made a bunch of decisions that turned out to be right. So I dedicated some time to being part of the OpenStack Foundation, right? Not just on the board, but like the drafting process and working with lawyers to create the structure of that, which included things like who gets to go to the summit for free and who doesn't, and how to become members and who gets a membership and how does voting work. And a lot of those things sound stupid, but they were really empowering for newbies, which is how you grow a community. People have to feel like they immediately have a place and they can immediately make a mark. And saying, hey, guess what? You can become a member before you contribute code. As an individual, you can become a member immediately. It's free. You get invites. You get to feel like you're part of a group. That was powerful. And then we had parts of the community whose full-time job was to make newbies welcome and help them land their first patch. And we celebrated them. So we gave awards at the summits to the people who helped the most new members, right? So we had this whole super user persona as well. Not just like you should commit the most patches or do the most reviews, but you should be the most helpful. That made a big difference. We were inclusive before it was cool, and we kept being inclusive after it was cool in a certain sense, for gender and ethnic diversity, which also meant hosting summits all over the world. that we got a little lucky on, honestly, because we'd had this weird partnership with NTT Data in the NASA days. And Jesse had gone to Tokyo to meet with them, and they were like trying to contribute to Eucalyptus with us. So we're like, hey, if we're starting OpenStack, yeah, it's like the Texans and NASA, but it's also the Japanese, which means it really needs to have this international community organization. How are we going to make that work? There are, I mean, Rackspace was incredibly helpful in their willingness to put money behind making the community happen. So the summits were funded by Rackspace for years, which meant they had cool venues and good food, and the AV worked, and we had infrastructure. And then we did our part at Piston. I started the OpenStack meetup program, right? And the first one was actually before we launched. It was at Hacker Dojo in Mountain View, and I just gave a talk, and I was like, hey, I'm at NASA and we're doing this thing, and it's cloud, and this is cool, and let's all talk about cloud. But we just bought pizza and beer and invited people literally to the Piston office, which was also my apartment at the time. And we would cram 80 people into this 3-bedroom space, and build code together, or just do walkthroughs, or help people understand what OpenStack was. And I still run into people who are like, do you remember? I was like, you were in my kitchen in 2011, I think. So meetups were, and then we gave permission to be like, hey, if you live in a town and you do OpenStack stuff and you want to run a meetup, just go ahead. Like, the bar was really just try not to be a dick.
I don't think you guys realize how impactful that was, because not to admit that I lost another fight to you at the same time, but I did. So I was over at Citrix at the same time, and we had bought Zen, which was actually a foundation to AWS at the time. AWS never really admitted it, but a lot of their early stuff was built on Zen. And we bought CloudStack. And so we had CloudStack and Zen. We had a competitive solution. So, and we had more POs. So we were winning more deals out there. And our statement used to be, hey, listen, POs trump PR. That was our standard statement on a regular basis. Turns out we were wrong, because we got ran over by the PR machine that was what you guys were doing. And it was amazing. And
that was Simon Crosby.
Amazing.
Simon Crosby, Gordon Mangione, and the Brit, the Cambridge guy. Why can't I remember his name?
Simon was also Cambridge, but yeah, the technical version of Simon. Yeah.
Ewan Meller.
Yes.
Yeah. Gordon, Mangione's great. I tried to hire him when we were hiring an outside CEO for Piston. He and I went through a whole interview process, and we couldn't make the travel schedule work because he was in Seattle and we were in SF, and we weren't doing remote, and he wasn't going to move. But yeah, no, that team was like, and there's, and I Shang from the CloudStack side, and there were a whole bunch of folks who were like pre-OpenStack, but doing open source cloud. And they're like, we have better tech. We're more mature. We have things in prod. What are these like hippies with Python doing? But I think the first year of OpenStack, I did like 50 public talks. Like I was at a conference preaching the gospel of OpenStack every week.
It mattered. It made a difference. We were focused on the commercial side. You were focused on the building community. Community won. Yeah. And community, especially in the open source world, we're starting to see that more and more. Community wins. Without a community around your stack, you have a stack. I don't care.
And I actually lost the plot on that commercially because I was so focused on having the OpenStack community itself be the community. And then commercially with Piston, I was like, we're doing our own thing and it's really for these use cases, that we lost the perception of being the company that represented the community to Mirantis over time, because Mirantis was just willing to pay a lot of people to work directly on core. And that's what I should have done. I should have raised enough money to just fund a big chunk of the community directly. And in retrospect, I was like, somehow it feels like Boris is cheating. And I was like, he's not cheating. He's just using my playbook better. Okay, fair. Like, yeah. So the community ended up winning even inside the businesses within open. If you look around at what OpenStack companies are still freestanding today, it's Mirantis. And that was why.
So this crew, especially, I think we would spend all of our time on the Wayback Machine, because there were some really fun times back then, and how we got here is important. But the conversation today is also supposed to be kind of where AI is going, and understanding where we came from is important to understand where we're going. And so we came from these big monolithic companies saying, hey, I'm going to buy servers ahead of time, to suddenly I need to do something on demand. I need to be able to grab things and go fast. I need to be able to stop and rewrite my code in a weekend and go in a completely different direction. That is the new world we're living in. Turns out that was always the world we were living in. We were just, now we're just a little bit more honest about it. And it's a little bit more democratized. More people can do it. Mm-hmm. But part of that democratization also means that there's a lot of people out there pretending to be experts in this field, and they're not. And there's also a lot of people in this field pretending to be people that they aren't in general. And so that kind of it's a little bit of a tee up to what Joshua, what you're building over at Polygard. And so can you kind of talk about what you built today and why it matters? And you were telling me a story about, when you were going out and talking to some of the folks grabbing or asking for cash, they were saying, this happens to be something that keeps me up at night. And so kind of walk through, the story and where you're at right now.
Yeah. I'll try and give a shorter version. All my answers are long. I apologize. I started writing software in '83, right? I'm very old. And in '87, I think it was '87, '88, I saw Max Headroom, which had just come out, right? This movie about deepfakes. And I was a kid and I was terrified. I was like, oh my God, there's a future where we don't know what's real because computers can generate something and you can't tell the difference. Hadn't happened yet. And then Jurassic Park was the first time we did face swaps of actors. And I started working in video games right after that in 2000, doing computer animation. And I was like, okay, it's coming. I can see a world where we get to, you can't tell if it's different or not, if it's real or not, but we're not there yet. But it was in the back of my head. I was worried. And fast forward through to NASA, I was like, oh, this is definitely like, we have the horsepower to do this now. We can, we're doing simulation video that looks like the real thing. And you can't really tell the difference, but it's still, we can see it coming, but it's not here. I started blogging about it in 2014, saying, hey, there's a moment where we can't tell the difference. And what does that mean? It means we need to have authenticity and provenance attached to media. Seems logical. 2017, the term deepfakes was coined. It's actually not that old. And then that came out. But I had it in my list. I keep a list of plausible companies, right? Stuff that I think maybe someone should build, maybe me someday. And I look at it every once in a while when I'm in between stuff. And I had this thing on the list of like real provenance for everything forever. And every few years I'd look at it and go, oh, we're not there yet. It's not the headline. And then, a few years ago, I was in between things and I was looking at my daughter's classmate had just gotten defrauded through an audio deepfake where somebody impersonated the bank and called him, recorded his voice, and then called the bank impersonating him. And then the Arup hack happened, and it was like a $25 million loss based on a deepfake video conversation in Zoom. And so I was like, oh, it's time now. Let's look at this seriously. And so our first versions for Polyguard were focused on provenance. We actually got some patents on using pulsar timing noise to sign frames of video and using lasers to embed those codes in real time. Cambridge just came out with a paper 2 years later. I think it actually infringes on our patent, but I don't really care because we're not doing that part anymore. And we realized in these early prototypes, nobody actually cares if the video is AI generated. They care about the identity of the person behind the camera. Mm-hmm. So you don't care if I look like a duck or I'm using some cool AI filter. You care about whether it's actually Joshua Mckenty sitting in front of the camera, regardless of what I look like. And we really, and I'm an X509 nut, right? I've been obsessed with identity and proof of identity for forever. And so it was kind of a nice realization to be like, oh, this is great. All I got to do is like actually solve digital identity forever. And then I solved the deepfake problem too. But but that's basically what we've been building. And yeah, it's going pretty well.
And so you're starting at X.509 as a kind of, I'm a little bit of an identity nut there, or a geek there too. And at some point, we solved that at Microsoft with Active Directory, right? So now everyone knows what it is, and we have a password. And then we realized, yeah, it turns out passwords not so good. And so we're evolving, beyond passwords and the rest of it. So we have identity, we have security, but talk to us a little bit about, this is beyond, passwordless. This is looking at it from a completely different space and looking at ability to identify somebody in a different way. So kind of walk through why that matters, especially in AI. And like you said, I don't care if you look like a duck. I care whether or not the duck who's speaking is actually authorized by Joshua to be providing these things. Because that also then means, because if I happen to be interacting with Joshua's agent, who isn't a duck, but it's just a code.
Delegated auth, baby. Yes.
So acting on behalf of, proving who you are, how is this changing in the world of AI?
Yeah. I want to reference Kamal's comment earlier about kind of early AWS era, where, Mike, you sort of pointed out, I was like, the feature was that I can rent instead of buy. And cloud was rent instead of buy, and that was the one feature. But it wasn't just the feature. There's only ever three things that change in tech, right? The topology, the speed, and the business model. And so cloud was kind of all three of those things changed at once. Networking. So again, I'm old, right? So I wrote software before there was networks, and then I wrote software on early internet. And then I wrote browsers where we started having the client server moment and web applications happened. And then I worked on cloud where the backend got split into pieces as well. And now AI era. And so the topology change that matters. Active Directory, brilliant piece of software, one of the best implementations of the directory concept ever, but it's a centralized IDP. We put all the users' identity in one place, and then you prove who you are by talking to that and presenting, here's what I know, here's what I am, here's what I have. Topology is centralized IDP, and the users are on the outside, and that model works when all your users are employees. Active Directory is an employee identity system. It's not a customer identity system. It's not what you use for users, right? That's where we end up with OpenID, OIDC world. And it's not for vendors, and it's not for strangers. So if you think about authentication of user-generated content, Active Directory does nothing there. And the model in an IDP is the trusted admin has to enroll the user, and then there is utility. And in the same, we've actually brought that same topology to user auth. You got to sign up for an account, and then you can get utility out of the product. And you are the admin of the creation of your account, which means you are then ongoing the admin of that account. So when you have an intern create your Facebook account, it's really problematic because you have to claw back ownership of the Facebook page from the intern. Because we live in this universe where the enrollment was such a key, and that's a topology problem because the identity is owned by the vendor. In the Polyguard universe, this is my IDP. My credentials are enrolled on my phone. My identity is on my phone, and I'm presenting my own credentials to your system, and you verify them based on cryptography. There's an X5C cert, and there's a public key registered, and you can trust Polyguard's chain of authority, but we're not the IDP. We actually have a lot of users using Polyguard who don't have an account on any Polyguard infrastructure. You can take an e-passport, be in airplane mode, scan and verify your identity and develop cryptographic credentials on your phone, and then turn airplane mode off and use that to authenticate using Polyguard. And none of the verification touched our servers at all. It all happens on the phone. We do full biometric verification, facial recognition on the phone. We're running TensorFlow models on the phone. We don't want your personal data, right? So if you, and I'll just rant here, this T app that just had this big breach, data breach, where everyone's driver's license photos and selfies were lost. because they were sitting in an unprotected bucket. I spent a bunch of time last night messing with IAM policy settings for S3 buckets, which is something I still have to do in 2025 because it's hard for a reason. And I am legitimately one of the better people in the world with managing S3. I've been doing it for as long as S3 has been around, and I don't want to have stuff in there that I don't have to have. Which means the stuff that's the sensitive data should stay encrypted on your device, locked with your face. So that's a topology change. And what it means is we're now in a world where you can verify your identity without enrollment for anyone who needs to verify your identity. And you can attach that to any action you're taking, and you can delegate that to any bot who needs to carry it around. But what you're sharing is not your underlying credential. I don't want to be flashing my driver's license or my passport every time I'm in a Zoom call because none of you are qualified to store it properly. T isn't, the OMB isn't, the DHS is not, even though they have the largest store of selfies in the entire world. You know, they're like, I have and have always had photos of my employees' passports because that's a thing you end up doing when you verify people's W-2s and I-9s and whatever. And then you have to put them somewhere. And then you have this ongoing long-term business risk. And nobody thinks about that until it gets stolen. And you're like, oh, when we actually fine you appropriately for identity theft in this era, identity theft in this era is not just going to be an inconvenience, right? Like if I know enough about Michael Cooper and I have Michael Cooper's biometrics and I can impersonate Michael Cooper, your life is over, Mike. Like...
Well, sadly, you do know enough to do. I'm just grateful you have other things to do.
Fair. My daughters use me occasionally to do background checks on like potential roommates or boyfriends.
And what you'll find out really quickly is your daughter's probably better at that than you are.
They're not, and it scares them a lot, and it scares a lot of their friends too. They're like, "How did you find those things about this person out and that quickly?" I mean, it's not that hard. Like, again, you're terminally online, right? But
yeah.
But that identity and that security, it's been a core issue with us since the early days. And the more things get virtualized, the more things get abstracted, the more dangerous that is. One of my favorite jokes I used to make to people coming into the Microsoft offices when I was doing their EDCs is, you know, before virtualization hit, before you went to private cloud, you had a security guard on your data center, and you were 100% confident that your data was still there. Virtualization hit, you virtualize these servers, an admin could have walked out with a copy of your virtual hard drives. So your VHDs, they could have left with your VHDs. And all of these big physical security guards with all these guns, they didn't stop it. They didn't know. So you can't tell me right now that your Active Directory servers, your whatever that was important to you, you can't guarantee to me they're still in your data center. They're not. Yeah. There's no way. And so understanding that we needed to actually put security principles around those things and ensure those things didn't actually work without some kind of an infrastructure was something that we didn't learn until, you know, a fairly long way down the path of implementing the technology. And so that Polyguard and people like that are starting to try and figure that out in the current world is important. But the concern I have is things are going to move faster than any of the technology is going to keep up.
I mean, the bad thing and the nice thing about realizing that everything is still an identity problem is it has always really just been an identity problem. And I remember I was at Sequoia trying to raise money for a company many years ago, several startups back. And I was talking to the receptionist or one of the EAs before the meeting was supposed to start and getting set up with coffee and getting in the right boardroom. And she was like, I don't understand why cybersecurity exists. Like, why do bad things happen on the internet? I was like, it's actually a great question. And I was like, the reason is when we went from the internet being ARPANET, and it was a nailed up wire between 12 different buildings, to being things that consumers could connect to, we made a decision to allow anonymity. That was it. If we registered an identity for every MAC address and you couldn't change them, there would be no cybercrime. If we had permanent and unchanging ARP table entries, your physical hardware was the thing that spat out that packet. Therefore, this bad thing that happened eventually is on you. All crime, all cybercrime could be traced later, right? We made conscious hardware decisions to say we're going to have anonymity and privacy at the expense of security, and then we're going to fight this war forever on the relationship between those two. And that's still kind of the case except that we know that it's more nuanced. We know that we're deciding where does the information live and who's allowed to get at it. And then the problem became, well, people want privacy, but the company doesn't because they want to monetize the data about the user. And the trade is the user's getting the service for free, so they're agreeing to give up the data, and then the data makes them vulnerable. Like the business model drove all these other weird problems, right? So if we look at this in the relationship of SaaS companies, and today, like, let's get super current now, because we're like, hey, AI is transforming everything. What do we care? What does this mean? The SaaS companies are all coming to us now because of this North Korean IT problem. They're like, hey, we're accidentally hiring people that turn out to be not who they said they were. Either they've paid someone else to take the interview for them, proxy candidate, and so they're non-qualified, or they're just literally not the person we thought they were. And not only are we have a data breach now, and we've wasted money paying someone who's unqualified, but also we accidentally violated international anti-money laundering sanctions because we funneled money directly to a hostile regime. How do we help us, right? And so, but that concept of like the IDP is for your employees. A candidate's not an employee yet. So the Polyguard is like, hey, we can give you identity verification of a candidate before the first video call and in every video call and in all correspondence. And we can tell you not only who they are, but precisely where they are, and confirm that it's actually them, that it's their presence, not just their phone. So you've got that on the, like, we're hiring people, we have remote employees. Then the SaaS companies have that for their customers, their end users, because increasingly, especially with agents, I mean, we had this with Mechanical Turk, right? We're like, hey, Mechanical Turk is amazing, invented by Amazon. And they're like, hey, let's turn humans into APIs. Great. Except the person doing the work sort of matters. People aren't actually fungible. Some of them have a PhD and some of them don't. Some of them are in America and some of them are in India. Okay, identity matters in that world. That world looks like more and more everyone. That's called the on-demand economy. That's like your Uber driver and your DoorDasher and your data labeler and. The more we have this kind of fungible workforce, the more everyone is sort of treated as if a freelancer, the less the idea of an Active Directory type IDP makes any sense. And also, the more vulnerable those humans are by being asked to present their real, permanent, long-term, durable credentials in each interaction.
And so one of the things you kind of mentioned along the way, but I do think we should double click on the use of it within the agents. And so the federation is what we used to call it back in the day, or I would give you a token, and now you can go do things on my behalf across the network. And so how does that change in AI? How does that change with agents, and what's Polyguard doing to address that?
Yeah, it's a great question. I'm topology obsessed. I probably, in retrospect, should have just gone to university and gotten a math degree and gotten really nerdy about topologies, because that's where my head goes. But delegated auth in the conventional sense, the OpenID Connect kind of world, says I make up a token that has a set of scoped claims and I give it to you and you can go do stuff on my behalf within that set of scoped claims. That's an okay model. It's sort of a pass it around. It's like giving someone a key. Here's the key to my house. Don't lose it. Try not to make copies of it. But that, like, it's not scoped enough. So then you want to say, oh, I want this to only be usable by this person, chain of custody against identities, and with reduced scope for a short period of time, right? And that's kind of where we are in the MCP world, where it's like, I have an agent that is talking to tools on my behalf directly. We're sort of getting there with these scoped token concepts, where we get to A, and we say, hey, my agent's going to go have other agents do parts of this work, and it needs to downscope that token to less and less privileges and never more, and shorter durations and more specific context. That isn't hammered out yet. Like, nobody's figured this out. And if you see the sort of recent Visa intelligent commerce workflows, they've announced a bunch of products and this like, hey, we'll bring Visa's authentication to bear on agent-based commerce. They're thinking in this single step model, right? Here's a dollar number. I've said, yes, agent is going to do the transaction. Well, but the agent might hand that off to 5 other agents. And some of those transactions might succeed and some might fail. And yeah, there's a bunch of other problems here. So we are, and I wrote this up again. There's a blog post I wrote on, it was called On Agency. And this is 2016, 2015. Before we were talking about agents, I was looking at this in the IoT context of, I have a fridge that orders milk on my behalf. And the service that connects my fridge to my Instacart account is provided by my telco, right? This was Swisscom was a big customer of Piston, and they were trying to do this B2B2C, my digital life thing. And so I was thinking about the auth problem. And the auth problem, my nickname was the M to M to B to B2C. Machine to machine to business to consumer auth. And that's a scoped token problem. What credit card is my fridge using to buy milk? And where is that credit card good? Which merchants can accept it, and how much and how often do I have to be in the loop, right? So the closest thing we have to this is like the broker-dealer relationship, where your broker-dealer is making a trade on your behalf and they send you this notice saying, hey, do you approve the trade? And you have to do it every time. And it's so dumb. I'm like, why am I paying you to do this if I have to continually say yes or no to every trade, right? But that's the state of delegated auth today. The topology is not right yet.
Now, strange question here, right? So, isn't that the problem that blockchain promised to solve, right? So,
I am the most long-term blockchain hater of anyone you will ever meet, because I know how it works.
I know. I also remember how it was. It was very scammy and things like that, right? But I was thinking now, we have this situation where we need to transfer. We need to enable agents to pay, right? So you need to identify yourself. You need to transfer somehow, money.
So the part of this that blockchain solves is just publishing keys. You need a place where the public key goes that everyone can get at. What we're doing instead of getting messed with any crypto world is just JWKS in a bucket on a well-known endpoint, right? So all you need from the publishing side is, here's the key that you can verify against. The token itself needs an architecture around expiry. There's like stapling and revocation, all these kinds of other problems. The problem with injecting blockchain into this space at all, especially when we don't know what the topology should look like, one, it's permanent forever. You can't write to the blockchain and erase it, which means you can't use it for anything that's privacy adjacent until you are 100% certain that you sorted out the privacy problems, because you can't go back and delete the data you accidentally wrote to the blockchain. So it's a terrible experimental protocol. And then the second issue is it's very slow, it's very expensive, and the assurances it's giving you aren't any better, in the sense of like, you're trusting a cert signed by someone. The only difference is, could be anyone in the world attached to any kind of wallet, but they spent at least a penny to do it. So you have some mental model that the cert is more valuable because it had financial encumbrance. That doesn't actually make it any more secure from an identity provenance standpoint. You're way better off saying there's an IDV, there's a Polyguard, or there's someone who verified someone's driver's license, and that's the root of trust. Or there's Appatest from Apple against this piece of hardware, and that's the root of trust.
So you're going now suddenly in a direction that we need central authorities that will be able to validate that transaction and say, like banks, right, in financials.
We need two anyway. We will always have at least two central authorities anyway. One is the hardware attestation. I can't trust a facial recognition scan unless I can trust the camera. I can't trust the camera unless I can trust the phone. The only person who can promise me the phone hasn't been tampered with is the manufacturer. So you got to do app test in the Apple world. You got to do Google Play integrity in the Android world to say I can trust anything, hardware root of trust. So you got to have hardware root of trust, which is a vendor of the hardware. And then you have to have a nation state root of trust, which is a vendor of identity. Self-sovereign identity is bullshit. It's great for social networks. It's shitty for commerce, and it's useless for agents. But so I have to have I am trusting a nation state to issue a credential to a legal identity with a biometric. It's a photo that can be, and the only one that we have that's an international standard today is e-passport. E-passport is a signed biometric that I can freely collect. We are, as everyone else is, hedging around the edges of photos and scans of driver's licenses, which we know you can fake for less than $12. But we can catch some of the fakes, and sometimes it doesn't matter that much. And at least we got a database look up, so we know at least there is a legal person with that driver's license number. We have no idea if the face actually matches, and neither does anyone else. But because the DMV doesn't share the face with you, you can't verify a face against a driver's license. Not for real. So there was this era where we said, hey, let's solve this with blockchain. Let's solve this with SSI. Let's let everyone live in, and we're just, no. It doesn't help. You still need it. You still need a verifier identity. You still need a verifier partner. And it could be a Polyguard. It could be, there's a universe where we say Google does this with Google Workspace Identity. And the problem is, again, it's in the Active Directory world. It's intended to be inside the domain. It's not fungible outside of the domain. And all it's doing is proving control of an email address. It's not actually proving a legal identity, which is also true in Active Directory. It's also true in Apple IDs, even less. Apple ID is just it's attached to a Apple person believes something, because Apple doesn't even guarantee to share a real email with you. So Face ID is a great device security mechanism. It does nothing for verification of identity.
I do think that nation state is, or at least one nation state we try, is becoming more and more true, because we assumed it was going to be some of the blockchain stuff. Then we realized that all they're trying to do is sell us coins. They're not trying to solve this problem. They're trying to sell us coins. And then we saw the emergence of Facebook and go, oh, okay, so it could be these, but Facebook lost a lot of trust in the last couple in those election cycles. And then we realized, oh wait, they're also just out here for the clicks. They're not genuinely trying to solve this "you are who you say you are" problem. That's not their need. That's not what their issue or problem is. So that's not what they're trying to solve it. That you can make the case of LinkedIn, but I think the problem is that there's a bunch of other folks out there who've kind of lost trust in the social in general. So I don't think it can be LinkedIn. So I agree with you. We're going back to the nation state.
Yeah, I mean, our most direct competitor is WorldCoin and Sam Altman. And Sam's decision is, hey, you need a hardware root of trust, and that's going to be us with the orb, and you need an identity nation state root of trust, but we're also going to play that role. And we're going to be the verifier. I was like, I kind of want those three separate, because I think it's a more scalable model and also less vulnerable to corruption and also data theft, right? I don't want data aggregation by one super party who also is building the AGI. That doesn't seem like the right model to me.
Exactly.
But the problem they're trying to solve is identical to the problem we're trying to solve.
All right, so we are at the top of the hour. I can't thank all of you guys enough. Mckenty, you're, as always, the genius and the legend that you are, and also a hell of a lot of fun to listen to.
It was so fun to be here. I feel bad. I just monopolized. I had all sorts of questions for folks, and I just got ranty on
if you weren't so interesting, we wouldn't have let you. It was worth listening to.
Yeah, this is a talkative group of guys. The fact that they weren't talkative meant that they were enjoying the conversation.
Exactly.
We'll have to bring you back. The one thing I do like that we started in the last episode, I do want to kind of continue it on, is what's the one new trick you learned from AI this week? And so I would like to continue that on. So if everyone kind of think of their answer, mine's going to be I am shocked at exactly how good Cloud Code is right now. It is mind-bendingly good. If you haven't, I mean, everyone's been talking about it, everyone's been playing with it, but my Lord, it really is that good.
Really good. Yeah.
Bill?
Yeah, I think just the inception story. I've been really getting into using AI to build AI. I'm not even it just, and again, this goes back to Cloud Code. It goes to like Q, to Q for developers. All of these tools are getting so much better at building themselves. Like I'm just, go build everything. Like just go look at these documentations and build. Like I'm not even in the middle anymore. I'm just standing there watching it do things for itself. It's just the snowball's getting bigger, and increasingly. I know somebody just recently said like 5 to 10 years before we're before AGI hits and before we're out of the business of doing this stuff. It feels more and more real. That's sort of been my insight for the week.
Yeah, it really does. Herman?
This week, actually, for the last 2 weeks, I one of the lucky people who can play with Amazon Kiro, right? Which is actually, IDE, so for developers. So why I like it a lot, right? So I used to use Cursor before, Visual Studio Code, and so what really is impressive is actually that specification first approach. And if you remember, Luke Ferris, our guest in a previous show, was actually saying that AI can write better specification than humans, and it can do that, right? So when I ask Kiro to do something, it first go and write specification for that. If I'm happy with the specs, then it goes to write a design document. If I'm happy with that one, it will create a task list, and now I can actually execute task by task. So I completely feel under control, and I really like that specification first approach. It's not a black box. I can still tune it. I can change it, right? So and it does an amazing job. I mean, in the background, it's still using Claude, right? So as an LLM, so it brings the benefit. But I think the whole idea about spec first coding, it's completely different than what I was actually doing before with AI coding.
Yeah.
Kamal?
I'll just continue the theme of the omni-straight. So with that respect, what's top of my mind is actually how to, like the traditional software is traditional software. We're calling agents as a modern software. What does it mean to how do we represent this modern software from the delivery point of view, and how it will be delivered and packaged together, and what does it mean? How from the characteristics point of view, it will be different from the traditional software. I'm just curious and just playing around with that idea, what that means for everyone out there. So it's a little bit big, but I'll leave everybody to their own imagination.
Well, he's got good points. I mean, building your next AI app is great, and turns out Cloud Code is great. It's amazingly good at it. How are you going to deliver that to your customer in a somewhat secure way?
Yeah.
You're hearing a lot of these, online guys talk about mini SaaS. There's no such thing as mini SaaS. SaaS is SaaS, and SaaS is hard. Mckenty?
I got two. One, I mean, just re-echoing, and we're using everything right now: Cloud Code and Cursor and Gemini, and so porting is typically an annoying, slow afterthought, right? So we built for iOS first, and we had to port for Android. We ported soup to nuts and made it through the Play Store review in under a month, and that's because Cursor wrote the vast majority of the port. We just pointed it at the iOS code. It was like, write a version of this in Kotlin, write a version of that in Kotlin, and then go clean up a couple of the edge things where the logic is not exactly the same. Wickedly fast. Where I'm playing around with now that I'm quite excited is we're using micro workers. Think of like Mechanical Turk, but super, super cheap. And we need real world usage data, performance data for basically every form of Android in every latency condition globally. And so we're just firing off like, hey, grab the app and scan this one Polyguard check, so we can see the performance of your user agent from that region. And all of the instructions I had Cursor write for me. But now I'm like, oh, I wonder if I can write an MCP server for micro workers and make that part of my workflow. So like, as I'm building out a new feature, I think about the unit test, I think about the integration test, and I think about the crowdsource test. Like, what if I put 100 people against this? And that can be part of my same workflow. So it's weird that we think about agents as being like, humans get to go use AI, but I also think we can now have AI go use humans.
Yeah.
And
Not sharing everyone, but like that's honestly where my head's at.
And I can't hear a single AI talk without the acronym MCP being thrown around about 4 or 5 times for something that came out 6 months ago, 7 months ago.
Yeah, October, November.
Yeah.
So like 9. But
my Lord, has it taken the world by storm? Saying, yeah, you know what? Why didn't we think of this earlier? This is what agents need. And so I do think we could probably do an entire deep dive session just on MCP, and probably should at some point, because
well, and to the point of like Bill saying AI writing AI, when you make your AI write MCP servers for you, it gets really fast.
It's very, right, exactly. There
Erica
goes
Windish
Skynet.
has been blogging about that, of like their workflow now is like the AI writes an MCP server, stands it up as a new tool, and then keeps going using the tools it just created.
Yeah.
Crazy.
I think there's going to be a lot more for a newer technology that is that is now kind of it is core to everything that we're doing. There's more to become. There's more coming with MCP.
Yeah.
Thank you guys. Great talk as always.
Fun.
I learned a lot. Also have a lot
Thanks
of
a lot.
fun. Thanks, guys.
Great meeting you guys.
Thanks a lot.
Bye, Josh.
Bye now.